Okay, so today we are going to walk through the majority of the slides from the Stanford NLP courses on lecture 15 on natural language generation. So the first section is about a recap of language models and decoding algorithms. So what is the NLG, natural language generation? So it's more like refers to any setting in which we generate new text. So if you think of machine translation, well, you generate new text of your target sequence. You kind of transform from your source sequence to your target sequence. So the target sequence is kind of like a new text, right? And then it also can be used in the summarization, where you summarize, say, an article into a few sentences. Right? It's a short paragraph or a few sentences. And also the dialogue, well, it can be a chit-chat dialogue, more open-ended generic dialogue, or it can be more task-based, right, to answer, for example, the Q&As of some surveys, etc. And also people use NLG to for storytelling, right? And also the input can also be an image, right? And the output can be the caption or description of that image. So you can see that NLG has a pretty wide application, and it has been used as a sub-component of many systems. So, and then the basic model from that is, of course, the language model, where we, given the words observed so far, like y1 to yt minus 1, we are going to predict the next word. And so this is called a language model. And if the system is using recurrent neural network, it's called a recurrent neural network language model. So always predict the next word. And then there will be conditional language modeling, because of so many tasks we have seen, there's some other conditions or some other input X, right? For example, in the translation, we have the source sequence, and in the image captioning, we have the X is the image, or in the summarization task, the X, the input is that paragraph or article, right? So we want to build a language model that is conditioned on some other input X. Right, so example of this conditional language modeling task, so machine translation, summarization. So in the dialogue, well, your X can be all your dialogue history previously, and Y, of course, is your next. So what to say next in your conversation. And then this is the basic framework for the recurrent neural network language modeling, right? So we have our source sequence, and then we encode them using a recurrent neural network, and then the hidden states is passed on to a decoder, is another recurrent neural network, right? And then we want to so the loss is the negative log probability. Right, so every time we just input the words, and then it will make a prediction of the distribution of the next word. And from that, in the training phase, they use a teacher forcing, which means they always use the true word, the ground truth word next. So it's a true label next in the training phase. But in the decoding phase, they are going to use the previous output as the input of at the next time step. Yeah, so this is a very simple recurrent neural network language modeling, and of course, people develop many like attention mechanism is kind of like by default right now to improve the performance of this sequence to sequence or even transformers, right, for the language modeling. And then there is a decoding algorithm. So what is decoding algorithm is because over here, you output is a probability distribution, right? From that probability distribution, you need to select the words, exact words next, right? So one way is you can always do a greedy way. You can always choose the word with the maximum probability, but there are of course many other ways to decode or transform from the probability distribution to actual selected word next. So the decoding algorithm is what you use to actually generate the text from your language model. So the language model gives the distribution, right? And then you need to generate text from that distribution. So in the decoding algorithm, they usually have a greedy decoding. They also have a beam search. So in the greedy decoding, they always use the argmax, right? So choose the word with the highest probability, right? And then they put this word next at the next time step, and then again pass through the decoder and then generate the distribution for the next word, and again select the word with the highest probability. But because this is a greedy approach, right? So without the backtracking, the output can be poor, because if you make one mistake at one step, there's no way for you to go backward and correct it, right? And then people develop the beam search. So the beam search is just instead of always choosing the high probability word, the highest one, but you can keep track of the k most probable sequence, right? At each time step, you can keep track of the k, for example, k highest probable words there. And then you basically just grow the branches, and then you always have a candidate pool of the sequences, and in the end, you choose the sequence with the highest probability. Right? And of course, you need to normalize, make some adjustment for the length, because the longer the sequence, usually the lower probability there is. So without normalization, you will always favor those shorter sequence. So you need to make some adjustment for the length. So this is one example, right? So if k equals 2, so at each branch, you just keep the 2 most probable words, right? So yeah, this is the same with the previous translation, right? So at each time step, you keep track of the 2 most probable words. And for these words, you again keep track of the next 2 most probable words. And once you reach the end token, right? For example, this branch was hit the end token earlier, so this is the relatively shorter kind of sequence, while you can also generate a longer sequence till hitting the end token, right? And then that completes this branch, and then you can do this backtracking of selecting the one with the highest. So here is the highest score, right? So this is the one it chooses after normalization, considering the length of the sequence. So this is the idea of beam search. And actually, this is also from the like a one screenshot from the West world, and it looks like what the agent is speaking is using something like beam search, like something over here. Like there are so many possibilities of what they want to say next, and then they just keep track of it and maybe, kind of backtrack to find the most probable sequence from that. Yeah, it's a pretty cool, and actually, well, yeah, maybe the apps in the West world do consider this type of algorithms to design their control for the hosts. And then, as you can see, right, so for the beam search, there's a K setting for the beam size, right? So when the K equals 1 is exactly the greedy decoding. The drawback of greedy decoding is sometimes you can generate not so good sequence. It can be incorrect and not fluent and natural, right? So it's that's the drawback of a greedy algorithm. But if you increase the K, right, so it means you have more hypotheses to track. But of course, it will become more computationally expensive. And also increasing K will actually generate more generic output. And so what does it mean is, for example, if you want to, if you train a chit-chat dialogue, so it's kind of open-ended conversation. And then this is human chit-chat partner, so if you say this, and then this is a different output when you change your beam search size, right? So when you set beam search size to be 1, you can see that the response is more specific and it's more focusing on the topic, but it's bad English, so you cannot, not that fluent and follows the grammar, etc. Right? But if you increase the beam size, it's kind of converges, right? Converges to a more safer and a more general response. Like, what do you do for a living? Like, but it's not very relevant for the previous question or conversation. Right. So yeah, you need to select the right beam size for decoding. Okay, so that's the first section about recapping the language modeling and decoding algorithms. So is there any questions or comments? Okay, let's move on to NLG task and what methods are people trying to solve them. And actually still, I think this field is still very challenging and also one of the most actively researched field. So you can see from that. So the first task is summarization. Right? So the summarization can be a single document or multiple document. Right? Given an input text X, which is a document, and then we want to generate a summary for that document. The target sequence is Y. Right? So it can be the single or multiple. When it's multiple, well, it can mean that they have overlapping content. For example, news. All the news articles are talking about the same event, right? And then you can let the model to work through all the news articles of the same topic and then generate a summary from that. So these are the different data sets that you can use to train a summarization model. Like gigawords, and so this is more like to summarize the news into a headline. Right? And then, of course, so there's also like news. So this is the news to headline, and there's some paragraph to some summary or news to summary. Right? So it may be a little bit longer than headline. Yeah, so these are all summary data. So this provides kind of the training and the toy data sets for you to try out. Yeah, and also there's another called sentence simplification, right? So you may want to generate or make the text in a simpler way, right? So in the Wikipedia, you may want to make a simple version of it. And even for this article, you may want to write a version just for the children. So you can write a shorter, easier to understand transformation for that. So they call it a sentence simplification. It's related, right? Because they are all talking about the same thing, but a different way, in a shorter, briefer, simpler way. So there are two main strategies for summarization model. So first is just to select parts, right? So like just the marker. So you just highlight the most important sentences in your documents and directly use the original text to form a summary. And then the second is abstractive summarization, where you generate new text. And actually it's more difficult, but it is also more human, and also it can write, I think, a briefer, a shorter summary without too much copying. So you saw when you go to a summarization field, there's always a fight over too much copying from the original text. About the evaluation, people use ROUGE. I don't know whether I pronounce it correctly. So it's a ROUGE score. So it's kind of very similar to the blue score. It's doing a recall on n-gram overlap. Well, here you just count the n-grams in your summaries, right? So when you set n equals to 1 is just a unigram, just one word. Or 2 or 3, right? So 3 is like the phrases of 3 words, and this is your total count of those grams in your summaries, and then this is the like how many of that grams match your ground truth data, right? So if it's a training task, and you kind of know the ground truth. For example, you kind of know your highlights or the summaries earlier in the training set, and you just count how many of these grams match. And then this is actually a recall, right? Because it's referring to the reference, the output you generated. Right, so this is based on recall, while blue is based on precision, but actually people most of the time use F1, so it's a combination precision recall to evaluate it. Well, it's just, I think it's just a statistical way to measure the quality of the output, but of course it's not, it works to some extent, but of course it's not ideal. And then it only reflects one aspect of the quality. We will talk about more about the metrics next. Yeah, so the blue score is usually an aggregated number, which is a combination of the precisions for 1, 2, 3, 4 grams. I think it's more like a weighted average of the precisions from the n-grams, while the ROUGE scores are reported separately for each n-gram. So you will see many of these like ROUGE 1, ROUGE 2 that gets reported in the paper evaluation, and people also developed a very convenient Python implementation of ROUGE, so you can directly use it to compute that. Yeah, so feel free to pause me for any questions, or you can type questions in the chat. So for the neural summarization task, so in 2015, people first published the paper using the sequence-to-sequence with attention model. Yeah, so we can directly apply the sequence-to-sequence plus attention model that was originally designed for machine translation. Here, for example, you have a really long sentence, and then this attention is kind of the highlights of of the word, like which part of the sentence or which maybe word gets picked from the long sequence. And that put together is a briefer version of this long sentence. Right, it works, well, to some extent. But of course, people later on realize that this type of systems are good at writing fluent output, but it loses lots of details, especially those rare words that are important, but they usually not picked in the summary. Right. So then people trying to include the copy mechanism. Right. So remember that two strategies, right? So one is copy, one is more generation of new text, right? So people are thinking about ways to how to incorporate these copy mechanisms into this model. Clearly, it's very useful for summarization, and also it gives us the opportunity to hybrid these two approaches together. And so these are a bunch of papers of, I think it's all published around 2016, while people trying to incorporate copy mechanisms. So here is one example that published in 2017. It's basically outputs the probability. Right, so this is still a sequence-to-sequence model with attention, right? So, for example, over here at certain decoding time step, you use the query from the decoder, right? The hidden states, and compare it with each of the states in your encoder, and then you generate a attention distribution, and then you use this attention distribution to calculate the weighted average of your hidden states of the encoders, and that gives you a context vector. So the context vector is kind of like the vector for the copy mechanism, because it tells you like which word, for example, which word to copy, right, to your final output. And P generation is directly from the decoder because it tells you a distribution of the next words to generate. And then at the same time, it generates a probability of P-gen, like for the final distribution, how many of the portion is from this language model, from this language generation model, and how many of it is from this kind of the context, this attention distribution. Right, so the final distribution is the combined vector of this blue and this green. The big problem with the copy mechanism is sometimes if you use that, they copy too much, and also sometimes they tend to copy long phrases or even the whole sentence, right? So it's not that abstractive. Another problem is they are bad at overall content selection. If the document is long, so it kind of like focus too locally on the data sets, and they don't have the overall strategy of selecting the most important content from the documentation. And then actually, then people borrow idea from the pre-neural summarization, where they have separate stages. Well, the first step is the content selection to tell like which content is most important, or what sentences are the most important, right? And then they make a summary from this important content and forget about everything else, right? So in our standard model, we kind of build an end-to-end pipeline, and then these two stages are mixed together, right? But this is, according to practice, this is bad. Well, sometimes end-to-end helps, right? But sometimes the end-to-end, at least right now for the language model generation, is not working as well as this two-step approach where you want some global content selection strategy, and then you surface your summary from the important content. And then people propose solution to do this two-step approach instead of just one end-to-end solution. So they call it a bottom-up summarization. Well, first they train kind of a sequence tagging model, right? So they first tag which words are important in the original source, right? So this is your masked source. For example, the red ones are the most important ones, right? And then when you generate your summary, you only allow your attention to just attend to these important words rather than every word. Right. So it's yeah. So it basically is just a two-step approach. While it kind of directs where your attention look for. Yeah. So it's actually a very simple idea, but people find it gives better overall content selection strategy and also less copying of long sequences. Right, actually, because you break it, so it's not usually it's not possible. Like every word of a long sentence is that important, right? Maybe it's just a part of it. So you already break the long sentence, and then you provide the most important raw materials for the sequence to sequence model. Yeah, so this model is proposed in 2018. I think it's a very interesting idea. And although simple, but it's effective to improve the copying mechanisms in the sequence-to-sequence model. Okay, that is summarization. So any questions? Okay, next task is dialogue. Yeah, actually the dialogue is the most intriguing one to me because sometimes I just want to like find someone to talk to, and it will be fun to see what the response are, right? If you train, just say for example, a chatbot, and it will be very funny to just watch how the chatbot replies to you. So in the dialogue generation, there are mainly two types of system. So one is a task-oriented dialogue, right? So for example, it can be a assistant type, right? So I think right now, many online kind of chat service, they have this type of chatbot there, right? So if you just search for simple answers, they can directly send you back the link or give you the answer, right? Until at some point you are bored with the bot and you say, I want to talk to a real person, I want customer service, and then they will connect you to a real person. Right, so this dialogue is more like help user accomplish a task, like for example, purchasing or booking anything or finding simpler answers. That can be also cooperative or adversarial. Yeah, but yeah, I haven't seen any examples like two agents compete in a task. Yeah, but it will be fun to see maybe in a, I don't know, negotiation type task, right? So they want to compete or bid, right? So if like two agents bid for a common product, like whoever wins, right? So they may need to be adversarial in that negotiation process. And the second type of system is a social dialogue. So it's just more general. We also call it chit chat. just for fun with a company, and also people use it for physical therapy. Right. So yeah, I think it's helpful that way to just talk to to relax. Yeah. So people, of course, people first try the sequence-to-sequence based dialogue model for the dialogue, but it quickly find that if we just train a naive application of these standard methods for example, for the chit chat dialogue, sometimes it just gets boring very easily. And sometimes when you ask it, it will reply with irrelevant response, right? One example includes, for example, we use in a beam search, we use a very large K, right? And then you see the response will get very general. Basically, that response can be used for any, no matter what input or what question you ask, it can always just reply back that. So it's not related to the context. And also it's easily to cheat the bot to get some repetition. And just keep replying the same thing. And also, for example, next of, they don't have a long memory of remembering what they have said a few times back, and also the lack of consistent persona. Well, different people talk differently in different styles, and they don't have a consistent styles of speaking. Right, so these are the main challenges to develop a dialogue system. And then people trying, well, usually they are trying to improve one aspect of it, because I think it's very challenging just to improve every aspect of it. And if you can improve one aspect of it, it's already a very good paper or very good improvement for the system. Right? For example, for the irrelevant response problem, well, maybe because it means your response is too generic, right? And or you just change, the body just keep changing the subject to something unrelated. So one solution is you need to define a good objective for your system. One objective is maximum mutual information. Right, so it's basically, so this is the mutual information between the input S, for example, the input you give to the bot, and the response. You want to maximize the mutual information between the two to increase the relevance. And of course, this form can be written as this form, like if you break down into a conditional probability and PT. So this is one way to just change your objective, or it can be some quick fix, right? For example, in your Bing search, if it generates some interesting words or rare words, you can upgrade them. You can give them higher importance to service them up, right? Because if they are rare words, it may be because maybe it means it's more relevant for the context. Right, so, and also people, of course, develop a different decoding algorithm in addition to BIMSM. They call it a sampling algorithm, because in that is a distribution. Instead of keeping the top, for example, the top 2 or top 3 most probable words, it just sample from that distribution. Right, so it's you give it a higher chance of sampling other rare words from the distribution as well. So if you feel free to check it out, I think it's also a very cool idea to surface up these rare words. It can be also this conditional fixes, right? So you can condition the decoder to some additional content. Another way is to use a retrieve and refine model, because I think this is commonly used in a real world system where you already design your utterance or what's the format of your replies look like, right? And then according to the question asked, for example, the online assistant bot, right? You just match the question to the most relevant predefined utterance, and then you just modify it to fit the current scenario. I think this is a very practical and good idea, right? So instead of generating from scratch, you can just choose from a pool of pre-designed utterances and then edit it to fit the current scenario. This usually kind of have more limited utterances, right? And also again, make it more human-like. And also it guarantees that the system doesn't output anything too crazy or generate too much surprise, right? So it is more controlled output. And of course, about the repetition problem, because the bot can easily reply with, just keep replying with repetitive n-grams. You can block this repeating during the beam search. Yeah, so this is more practical tips, I think. The more complex solution is you can redesign your objective to prevent the attention to attend to the same words multiple times, right? Or make it harder to attend to the same words. Or you can just train your objective to discourage the repetition. But sometimes if you add, for example, the repetition is just count. That's one quick way to measure the repetition, right? But the count is not a differentiable function, so it's hard to train it. And then you find to use some other techniques like reinforcement learning to train to search for to maximize the objective. And regarding the lack of consistent persona problem, is you want to have, of course, the most direct way is you want some measurement of the persona, right? How can you quantify the personas? Right, so then people find, okay, maybe we need to learn the embeddings for the personas as well, and then make them as input. Right, so the personas is, once we are able to embed them, and then they can become the input to the condition. It can become as one of the inputs, right? And then in a chit-chat data set like this, they use a connection of 5 sentences to describe these personal traits for every conversation. So if you speak like 5 times, it kind of reflects how you, well, you can of course make this longer sentences or like 10 times, but it kind of already measures the style of how you speak. Right. So I think it's good idea to incorporate or learn the embeddings of the personas from that. So feel free to read this interesting paper, like how to personalize your dialogue agents. So this is the dialogue applications. So you can see there's always, there's some basic system. For example, if we just use sequence-to-sequence attention model, and then people identify a bunch of challenges and what doesn't work, right? And then people develop ways to tackle each of them individually. So it's, and that's, how this field get evolved and get improved over time. And then there's a separate task for question answering. Right? Earlier we have seen the dataset, SWOT dataset for question answering task. And then here is like, in addition to that, we want to do this question answering given a context of the conversation, which is this paragraph, and then we want the answers. We want it to be in a form of this conversational way, right? So it can be both the bot and then the person is know something about the context, or maybe just the bot know about the context, and then some people is asking the bot about it, right? And then the bot replies back with some natural language. Well, it can be just as Q&As, right? Just replies exactly the answer, or it can be more dialogue style. It can be more, although abstractive, but it's more in a more natural language way, right? To be more user friendly, I would say, and also shows you some proofs and support from that. Okay, so this is the different applications of the NLG, and then let's move back to the evaluation. So earlier we have talked about the ROUGE score, right? So all of this is and blue score, and of course F1, and I don't know what this score are, but it's I think very similar statistical kind of word counts, word overlap stats based metrics. Although we know they are not perfect, right? And sometimes a good response can result in very low score. But people kind of but they still kind of reflect something, right? And people actually use them for machine translation and many tasks. And these metrics are commonly reported for that. But people also realize that actually when we use these scores, it is much worse for summarization and much more worse for the dialogue. So yeah, so that means we need to find new scores, new metrics, or maybe we just need a human evaluation and try to make the human evaluation more objective rather than subjective. And then people study how these scores is related to, or maybe not even related, correlated with the human evaluation performance. And so here is an example of saying the word overlap metrics are not good for dialogue. So here are the two data sets, and then people they use some human evaluation, right? So the human score how good the dialogue is, right? So whether they're interesting, whether they're whether you want to talk to the bot again, whether they talk like a person, etc. Right? So they do a survey of that, and then resulting in some human score, and then they use this statistical word overlap metrics. And in comparison with the human score, you can see that there's no very low correlation, right? So it's almost flat and random. So it means, well, the scatter plot shows the correlation actually is very low. Maybe it's not even correlated at all with the human judgment. So it means this was actually very bad at capturing the quality of the dialogue. Well, if you generate a human score from a group 1 of humans, and then you can, of course, again, to get the scores from a different group of people. And you can see that the scores are very correlated. So it means that the humans kind of, although humans are subjective, but they still follow or still consistent in some sense, right? So you can see that they are not correlated. So this is the performance we want. We want to some metric, or maybe right now it's impossible to find such automatic calculated metrics to match the score of human, right? To show this highly correlated performance on that. But at least the conclusion, we know that all the earlier reported scores are not effective to evaluate the quality of the for example, the language generation task. So there are automatic evaluation metrics for NLG. So people saying, what about using perplexity? So the perplexity is a measure of how well a distribution predicts the sample. So it basically just measure that the probability, right, from that language models. But it doesn't measure the performance of the decoding, because the decoding, as you can see, is very important, right? So that beam search and all that, right? So when your K is small and K is big, although they all use the same language model distributions, but they can generate very different outputs. So perplexity only measures the language model, but it doesn't measure the quality of your decoding algorithm output. And also people develop the word embedding based metrics, right? Just to compare the similarity of the word embeddings, compare the similarity of the language embeddings, but people still realize that it doesn't correlate very well with human judgments for the task like dialogue. So in summary, we have no automatic metrics to adequately capture the overall quality, but we can design more focused automatic metrics. And so we can design a separate metrics for separate things. Right? We can design metrics for fluency, for diversity, right? To see whether the outputs use the real words and the uniqueness of the n-grams. We can define the relevance, right? And also measure the things like the length and the repetition. So if we just focus on one aspect of the performance, we can do a relatively better job rather than trying to find an overall metric for human quality judgment. Right? So even though this doesn't measure the overall quality, but they can help keep track of some of the most important qualities of the systems. So yeah, because we don't have the overall qualities, and then the human evaluation judgments become the gold standard, right? So and of course we know that it's slower and more expensive, but humans and in addition to this, humans can be not that consistent over time. We can lose concentration, and sometimes we just don't we may understand the question in different way given different backgrounds, right? So if the system asks us a question, we can interpret it in different ways, and therefore the response can be very different. And also we sometimes just don't explain why objectively, like explain why we give this score of 4 instead of 5, right? We just say we feel that way. Maybe we have our own different standards or comparisons, right? So still, well, it's a gold standard, but it's still very difficult to conduct a human evaluation effectively. So this paper is also very good, interesting to read, published in 2019. So what makes a good conversation? And it tries to relate the controllable attributes to the human scores. So the controllable qualities such as repetition, whether it's relevant response, right? Like how much is related and task specific, or whether the bot ask questions back, right? So these are very easy to control the system to do. And we want to see, if we do this, we want to see how the human judgments and human evaluation are going to change because of this difference, this controllable quality of the dialogue of the chatbot. And then, so, and then for the human quality judgments, we try to make it as objective as possible, right? So one way to do that is we make the question more specific, right? So for example, like, these are more like overall quality question, right? So like how engaging of this, which of this gives a better response? Do you think it is a human or a bot? Right. So it's a very general type of questions. So the major problem with asking questions in survey like this is the response can be very subjective and people can have different expectations and as such. So it means that we need to ask more specific questions instead of these more general questions. So then when they design the survey, so they design the survey as whether the response avoid repetition, whether the conversation is interesting or not, right? Whether it is fluent, right? So they actually more focus on one specific aspect of that. And of course, we also at the same time measure the overall quality from the human judgments. And then we can actually control the dialogue in certain way by doing this, right? So we can make the dialogue more repetitive and such. So we want to relate these low-level controllable attributes to the human judgments of the conversational aspects. Right. So we want to see if there's any correlations and that. So the findings from that is, I think, is very interesting because, for example, people find that study that controlling repetition is extremely important because we are just so good at detecting repetition, right? So if you repeat too much, the bot is repeating too much, we can easily get bored. And actually, if the bot asks more questions, improve engagingness, right? It improves human to intrigue people to chat back. Like also, if the bot is able to generate less generic utterance, it also improves the interestingness and perceived listening ability of the bot, right? So yeah, so humans actually have a very low tolerance for the risk associated with a less generic bot. So if the bot generates a non-sensical or not so fluent output, human can easily get lost and just stop talking back. So yeah, so this is kind of very interesting to see how humans interact with the bot with the different qualities. And then the overall metric enjoyment is easy to maximize from their study. For example, the bot can reduce the repetition, can ask more interesting questions, but the Turing test is not at all easy. And of course, so all the bots so far are still far below the human performance. But human itself is not the same as the conversational quality, right? So humans actually are suboptimal. So for us, so we can score poorly on the interestingness, fluency, and also we may ask too few questions. So we are not good just in terms of this quality and evaluation. We are not actually optimal conversationalists ourselves. But I think we are all getting, well, I think this reflects why we are humans, right? So it's if we score, I think if we are optimal ones, and then I don't think the humanist score will get, I guess, lower. I don't know. So yeah, So it's interesting to see that the humanist and the optimal conversationalist is not the same thing. Okay. So here is the evaluation. So the summary for the evaluation is very easy. Well, right now maybe not possible, and people hasn't find a very good metric to capture the overall quality of the system, but rather people design different metrics, right? So design different metrics for different aspects of the system. And the human evaluation is still the gold standard, but when you do the human survey, you need to make the human judgments more concrete, right? Instead of asking more this type of more general type of questions, you can help human to focus on the more specific aspect of the quality, right? So that people can get more objective. You can get more objective response if you ask more concrete question. So the section 4 of the lecture is more thoughts on the research, current trends, and the future. So I have removed a bunch of slides, so feel free to check the original slides, but I have listed here the 8 things we have learned from working in the NLG field. So, and of course, so the first lesson we learned is the more open-ended the task, the harder everything becomes. Right? Actually, so it's good to have constraints rather than you just go free without any constraints. So actually, it's much harder to solve the task without the constraints. And the second is, yeah, we need to aim for more specific improvement than to improve the overall generation quality. Then, as you can see, for example, the repetition, the relate list, and all that different aspects of the generation, right? So at one time, we can just focus on one specific improvement. And that will be much easier to manage and also will gain you more better improvement at incremental step. Yeah. So if you are using a language model for the NLG, so improving the language model will most likely also improve the generation quality. Yeah, so it's very related. And of course, it's not the only way. There are many other ways of practical tips to improve the generation quality. Right? As simple as, for example, you just in your decoding, you just try to avoid repetition there, right? Just don't generate sequence with repetitive sequence or phrases there, right? But of course, always improve the language model is one direct way and an important fundamental step to improve your generation quality. And also look at your outputs a lot. So especially if you realize, oh, your output is too general, right? So it's maybe your K, the Bing search K is too large. And I mean, look at your output is a great way to debug your system, like to see what works, what's the problem with that. Whether it repeats too much, whether it generates copy too much, right? Copy the down sentence from the original text in a summarization, or it outputs too general. It's not learning the context too much. So by looking at your output, you can easily diagnose the problems in your system. So you need the automatic metric, even it's imperfect. So yeah, so right now we don't have the overall, like general metric to measure the overall quality for the NLG task, but we can have several automatic metrics. So and actually several automatic metrics can easily help us diagnose the systems to see the system, which aspect is doing great, which aspect is doing badly. And then we can focus on one aspect to improve. Right? And if we are going to do the human evaluation, we should ask the questions as focused as possible. So instead of just asking, well, is the bot doing a great job, or do you want to talk to the bot again? Like this type of general questions, we should ask questions like whether the bot is repeating too much, right? So, or whether the bot is asking bad question or like that. And so you should make your survey questions as focused as possible. And reproducibility is a huge problem. I think it's not just in NLP, it's in the whole area of deep learning. Sometimes it's and it's a huge problem in the NLG, right? So they recommend to publicly release all your generated outputs along with the paper. So the last lesson they learned as NLG researcher is it can be very frustrating because there's so many issues to fix, but also very funny because if you design a bot, right? So if you talk to it and if you see the response, it just gives you a whole bunch of large laughs there, right? So some bizarre conversation with the bot. Yeah, so I think I don't know where this is, how this is generated or where this come from, but it's it's really funny to see the response of just a sequence to sequence follow. And yeah, so it's a very funny field to work on. How do you get away from users of the bot making you? Yeah, well, you don't have you need to detect, I think, whether the bot knows or the questions the user asks falls in the range of the knowledge that the bot can answer. Right? So you may need to, for example, generate or predict some relevant scores. Right? So whether the bot has the knowledge relevant for that question. So if not, then maybe directly point the user to the customer service or some other resources rather than just generate this random weird response. I think it's still very challenging to put a bot in production. Right? So I think one way to really put a controllable bot is like earlier, like you have these pre-designed utterances, right? And first you need to define the scope, at least right now, because don't think the general bots still like work that great right now. So you need to first define the bot, what kind of scope your bot can answer. Right? And then second, you need to control the response of the bot. Right? For example, you can have some pre-designed templates for the bot to modify or to fill. Right? And then the bot, according to the relevance, the bot can choose the utterance to response back. Okay, I think that closes today's NLG session. So I hope you enjoy the afternoon when it almost just past an hour. Just work through the key. It's not like a detailed introduction of one specific model. It's more like a walkthrough of different applications, what problems each model has, and what's the current challenges with the methods, challenges with the metrics, and what are the practical tips that people are striving to solve and to propose. Right? So I think it's still a very challenging field for the NLG. Yeah, but it's also very funny field to work on. Is there any other questions or comments or some other funny stories to tell?